I hope my screen is visible to you guys if anyone is gonna watch. Quick time player, let me open my screen. I mean, yeah, so everything is ready and I can open notebook. And yeah, let me. So we have already white paper, not it's paper, whiteboard. Okay, hey guys, so I hope, let me just see. I'll start it. I just wanted to see if it is stream is working or not. Okay, so let me see it. Just let me watch it once. Okay, hey guys, so I hope, yeah, so it's working. So let me close it everything. And yeah, hi, so it's day 14th of DSA learning, and we made so much progress, or you can say we made pretty much progress. And yeah, so I'm ready with, if you see, my beard is looking little weird. Beard is looking weird, and the reason for that is like it need a cut, and I'm just avoiding from 3-4 days. I'm just saying like I'll go for I'll go to barber shop tomorrow. Then once tomorrow will come, I'll say it maybe day after tomorrow and all. Let's keep on going. I mean, keep on. I'm just keep on procrastinating. So no problem. That's not necessary as of now. So our goal is to learn DSA as much as we can, or you can say we need to strengthen, or we have to train our brain so that it could adopt, or it could tackle any kind of problems, and it could start by. I just wanted to basically, what do you mean? I just wanted to, you can say, make the make brain capable of like doing all the things in a way. What is this? So why it is showing current max 0? Okay, yeah, now it's perfect. So we are seeing a streak as well. Okay, so welcome to this channel, and if you are watching, or if you are gonna watch in future, then let me just tell you. So we are just we made a pro target, or you can say we made a, no, not so, we do not made it. Basically I placed that I I placed that I'm gonna uh, not stop this time. I'm not gonna stop, or you can say I'm not gonna stop until I'll finish the DSA, or until I'll be comfortable enough to tackle any kind of problems. It could be related to product based company, service based, whether it's, but I just wanted to be strong enough in DSA that I can tackle, or if someone who gonna ask me like, can you solve this problem, then I can tackle them and I can solve them. So that's our goals, and for that, like, we are going to uh, we are going to process, or you can see like we are going to continue it until will reach till a level where I'll feel confident enough that I can solve any problem. Till then we are going to continue it. So as of now we are just learning, you can say, array problems, and we have covered so far basic. Okay, let me just, no man, I don't know what is this, turn off. I'm sorry, is it not working or what? No, you can't be like this. Okay, wait just a minute. I think something is wrong. Oh, what's wrong with it? Huh? So now I guess it will connect. Just give a second. Man, I'm really sorry. It's not working or what? Yeah, you can see I'm connecting using Camo Studio. So yeah, so we are in the expert section, and so far we have covered 3-shum and 4-shum problems. So yesterday we tried to solve them, and yeah, for 4-shum I do not need Actually, for Fosham, it's like related to the similar to the threesome. If you know how to solve threesome, then you can solve the Fosham. In case of threesome, let me just revise or maybe just tell. Like in case of threesome, what we are doing, uh, we are fixing a number and then we are trying to find using two pointer approach. We are trying to find the pair that can, you can say, opposite. So here the goal was to find the zero target, or you can say target was zero, but here, okay, why it is showing cat may, bro, will you please stop it? This emoji hit me. Okay, so now, and for in case of Fosham, we tried to fix two numbers and then we tried to follow the same approach as threesome. So it's pretty much similar to the threesome, or you can say it's similar to the threesome. And the corner cases was to consider zero, and I think corner case expert. Okay, so let's jump to this problem. Let us find the repeating and missing number. Find the repeating and missing number. Okay, great. So let's jump to this and we'll see what could be the possible option to solve this problem, and also we'll try our best. No, we can't say like we are going to try our best, but our goal is to fix this. So can I give it time of 45 minutes? I think that will be pretty much time if you are getting solution. So if you are taking in 30 minutes to solve and write down the code on paper, then it's okay to you can easily write down the uh, problems. Basically you can write down the code in 15 minutes. That will be pretty much enough if you have if you have written code on paper and you executed it properly using the dry run with the examples and dry run. So that will be pretty much time to solve it. So let's target it, like, let me just, if there is any timer, then I'll gonna, if there is any timer, is there timer? I'm not sure about it. Timekeeper. Okay, let me share it. Okay, so we have 30, so I'm just assuming time 30 minutes of time, and it's pretty great. So first let me, I just started the timer on my notebook. You can say, given an integer array num size of n containing values of from 1 to n, and each value appears exactly 1 in the array except for a, which appears twice, and b, which is missing. Okay, so there are two numbers, one is missing and another one appears twice. So you can say, uh, instead of b we placed a, and because of that it's twice. So return value a and b as an array of size 2, where a appears in the zeroth index and b in the first index. Okay, that is simple. So you are not allowed to modify original array. You are not allowed to modify the original array. Okay, great. 3 4 3 5 4 1 1. So you can say 1 and 1 2 3 4. So 2 1 and 2 is missing, and you can say 2 is missing. So yeah, great. Okay, let me note down. So we have 3 4 5 and okay, 3 5 4 1 1. 1 2 3 6 7 5 7. Okay, these are the inputs, and you can say we can get the, so num length is 10 raised to the power 5. So it's like n can be 10 raised to the power 5, and n minus 2 element is the nums appear exactly once, and one and are valued between 1 and n. One element is in nums appear twice and is valued between 1 and n. Okay, so we have all the information, and now I can jump to the whiteboard and let's see how are we going to approach this problem. So I mean, if we have n of size 10 raised to the power 5, then I mean we can jump into the n log n solution. And if you see, so for this problem, one approach is just approach one, let me tell, that is very simple. Sort the array, okay, and then start tracking. So if ai equals to aj, that means you got that number. Also you need to count, so that will be the number that is duplicated, so that you can easily track. So another thing is like you need to find out the number, so you just have to, how are we going to track those numbers? And I can see another approach will be, and I know one option is just sort the array, okay, and after sort find duplicate. Okay, let me say it like this. That is the first approach that is coming into my mind. Sorry. Okay, so first step would be to sort the array. So we need to sort the array. After that, easily we can find out the duplicate. If like we will start with this number and we'll see if previous number is equal to this, then that we can say this number and we can stop it. So once we got the number, then we can say if the size of array is n, okay, then that means right now we have n minus 1 numbers. We are just going to you can say just calculate this sum of all numbers minus just deduct that number. So you will be, suppose total is n and duplicate number, just subtract it, so you will get the distinct numbers sum, and you have to add one more, or you can say into n plus 1 by 2. That should be the sum of all the numbers, but you just subtracted the duplicate and you can easily get the number. I mean, what I'm saying, simply get the sum of these numbers, and whatever the sum that we are getting of these numbers, and we are expecting the sum of all these like if total there are n, so n into n plus 1 by 2 minus you can say whatever the value that we are getting, so you can say sum minus remove duplicate, and that will be total, you can say, and the number that you are getting, that will be the result. Okay, so this is one approach, but here we are not targeting that kind of scenario. So if we are not planning to sort it, then what is another solution? Okay, can I do one more thing, like maybe you can say 2, so total there should be n numbers. Easily you can get it. Okay, so for example 3 5, you can say total numbers will be n, and we know there will be only one numbers that will. Okay, the problem is, okay, got it. I got it. You can't solve it using this approach because You never know which one is the number that is missing. It's like it's not like we have all the sequence of numbers. So, for example, here 2 is missing. Yeah, but I told you another approach, right? And that will work. You have to find the duplicate and s minus duplicate, just remove that duplicate, so you have remaining numbers and those numbers, and one number will be missing from it, so n into n plus 1 by 2, and minus s, if you will subtract, then you will get the number that you are looking for. So this one will work for it, and we can solve this using this approach, order of n, log n. But what if I do not want to use, okay, then we need to perform something else. Okay, so I'm just expecting some other solution. So we already passed 10 minutes of time elapsed. So 10 minutes already elapsed, 9 minutes. I'm just looking for some better approach here, and to be honest, haven't thought about it. Okay, so what if here we'll use hash map? We know all the numbers are unique, so we need to use something that all the numbers are another option will be use hash map. Okay, so you will get, and now we are looking for numbers between 1 to, for example, here the total number of elements, that will be 1 2 4 5. So you start from 1 to 5. Okay, and just see how many times 1 appear. If it appears twice, then you can say it's duplicate. If any number is missing or count is 0, that means that number is missing, so you can easily get that number. Order of n log n, yeah, but it is taking order of n extra space, and that we are when we are sorting, then we are minimizing that step. But can we solve it using order of n only? 3 4 5 without sorting? How can it? If we are not using hash map, we are not sorting it, then it's very difficult to solve it. Or maybe if there is any other approach, then I'm not sure about it. And let me now see. I feel like these are the only approaches that fact when. Oh, what the hints? How many options or approaches? Tutorial. Let me see. And now the elements with frequency 2 will be repeating number, and okay, this one is not. Okay, I don't think this is the. So they are using mathematical formula. S2. Summation of the square of all the elements in the given array. Oh, I am not expecting to solve mathematically problem. Okay, Zor. Zor. Man, this is something crazy. One minute. 3 1 will be 0001 and 10. Okay, for first step. How? Find the both. Find both the repeating and missing numbers. First compute the jar of the repeating number x. One to n, all the numbers, and here n minus 2 all the numbers, and one number will be mm, x and missing one number. So we are going to all the values will be 0, and then will be having, you can say 2, you can say 1. The one above will be two numbers, one x will be there, and so can I say from this we'll get one number, that is uh, missing one, and from below we'll get duplicate, missing or duplicate. Yeah, these are the things that will be for the first step. Iterate and calculate the jar of all the arrangements and the number between 1 to n. Let's call this value xr. Find the position of first set bit from the right. Bro, I did not get it. For the first step, iterate and calculate the jar of all the array elements and numbers between 1 and n. Okay, I know this. So after that, we'll get missing number and jar duplicate number. In order to find the position of first set bit from the right, either use the loop or perform. So if whatever we are getting the numbers, that means if the first number is same, if the value is 0, that means bit is same, 0. Opposite means 1. Okay, same 0, opposite 1. So this is how it's going. In order to find the position of the first set bit from the right, either use a loop or perform AND of the either uh, XOR and hyphen XOR minus 1. For the first step, iterate and calculate the jar of all the array element, and in order to find the position of first set bit from the right, either use a loop or perform AND of XOR and negative negation of XOR minus 1. XOR minus 1. Okay, so when if you are subtracting one, then it will be all the bits will be shifted towards right. You can say. Uh, Suppose it is 3, then it will be 2. If it is 4, it will be 2, 3. So when will it take and we'll get the first. Now take two variables, either 0 and 1. Check the bit of the not getting it. And I need to put more effort on what, bro. This is not going to help. So is 20. Okay, sorry, my bad. 19 minutes, and I feel like I need to refer. I think I used this method. I learned in the past. I don't know.
And 1 is 0, 0, 1. It's a part of 0. There are Zor and all of these things. You can stop over. But those steps were super intuitive. X will be my repeating, and Y will be my missing number. Again, assumptions taken initially. Let's quickly do one. Let's Zor all the elements of the array. All the elements of the array. And along with this, let's Zor all the elements from 1 to n. In this case, 1 to 6. Initially, we'll be using the Zor concept. So if you don't have an idea about bits, Zor, and all of these things, you can stop over here. Probably you can watch it after some time when I will be teaching you bit manipulation. And if you have idea about bits and everything, you can definitely watch it. So Zor method is what I will be using. Again, same thing. I will say X will be my repeating, and Y will be my missing number. Again, assumptions taken initially. Let's quickly do one thing. Let's Zor all the elements of the array. All the elements of the array. And along with this, let's Zor all the elements from 1 to n. In this case, 1 to 6. Perfect. So if you know one thing, in Zor, same numbers. If you Zor 1, Zor 1, it will be 0. If you Zor 2, Zor 2, it will be 0. But if you Zor 2, Zor 2, Zor 2, it will be actually 2 because 2 and 2 will go off, but there will be still 1 to left. So even number of same numbers on Zoring gives you 0. Okay. So can I say 4 and 4 will go off? So it will give you 0 Zor. Perfect. 3 and 3 will go off. 6 and 6 will go off. 2 and 2 will go off. 1 and 1 will go off. And you'll be left off with 1 Zor 5. It will give you some value. Yes, it will give you some value. If you try to find out the value, it will be 0, 0, 1, 1, 0, 1. So this is 1 and 5. And if you try to Zor it, it will be 0, 0, 1. And the value that you will get is 4. So the Zor of 1 Zor 5 is 4. And I assumed 1 to be x because 1 is the repeating number. And 5 is.
I do not want to. Basically, I'm just using it, but you can't see. I'm not trying to share it to you or what. I'm just trying to get the solution for this, so I'm just watching it. Okay.
The missing number. So I can write it as x Zor y equal to 4. I know this thing for sure. So can I say one thing for sure? I have two different numbers. And if I have two different numbers, the Zor of two different numbers will be different at 1 bit. Please hear me out carefully. Since they are two different numbers, they're bound to be different at 1 bit minimum. What do you mean by bit?
Yeah, you can say.
This is the 0th bit position. This is the first bit position. This is the second bit position. By the way, 0 in bit manipulation is written like this. 5 in bit manipulation is written like this. And this is the 0th bit. This is the first bit. This is the second bit. So if you have two different numbers, they're bound to be different at 1 bit. So if you see they're same at this bit, they're same at this bit, but they're differentiating, they're different in this particular bit. And that is the reason you go to 1, because same bits will always give you 0. Same bits will always give you 0. But there's one different bit, which is here. So in code, you just have to find one different bit. That is what you have to do. So in this case, probably I will say the second bit is the different bit. You can just write any of them. If it's a bigger number, there will be multiple different bits. Over here, we just have 1, and that is enough. And there will always be 1 because both of the numbers are different. They are bound to be different at 1 bit. So you just have to find that 1 bit. And in this case, I'll probably take the rightmost. That's an easier thing to do. So I'll take the rightmost bit. So what I've done is, I've taken the rightmost differentiating bit, which is the second one. And probably I can write the bit number as 2. Done? I know the differentiating bit. Let's omit everything. Let's try to focus on the approach. So I know the differentiating bit is 2. Over here, what do we have? We have numbers like 4, 3, 6, 2, 1, 1. Correct? And we also have numbers like 1, 2, 3, 4, 5, 6, which we do. We took this entire number in the like all the elements in the array, and we took all the elements from 1 to n. Can I say one thing for sure? The second bit position, it will either be 0 or it will either be 1. Like that bit position can either have a 0 bit or it can either have a 2 bit, right? And over here, if I try to count, 1 is happening to be 3 times. Please focus. 1 is happening to be 3 times. And 5 happens to be 1 time. Carefully observe. 1 happens to be 3. 5 happens to be. All the other numbers happens to be twice. All the other numbers happens to be twice. All the other numbers happen to be twice. So I know one thing for sure. Someone make the repeating number is thrice. The missing number is once, which is odd. Which is odd. Let's try to now solve. So if I take 4, can I see? If I try to write down 4, that is how it is. The 4 will be looking like this in big. And the second bit is 1. So 4 will be a part of the bit where we have 1. Okay. Then if I try to take 3, 3 will be written as probably 1, 1. So the second bit is 0. So 3 will be a part of the guys who are with 0. Okay. Then we have 6. What is with 6? What's the value of 6? 1, 1, 0. So it's basically 1. So 6 will be a part of this. Next, 2. What's 2? 0, 1, 0. So it's a part of the 0. Then we have 1. And 1 is 0, 0, 1. It's a part of 0. Then we have another 1. It's again part of this. Then we have another 1. It's a part of this. Then we have 2. And 2 is nothing but this. So it's on this part. Then we have 3. And it'll always be part of this. Then we have 4. It'll always be part of this. Then we have 5. And carefully observe. 5 is 1, 0, 1. And it has 1. So 5 will be a part of this. This is the bit number. And these are the numbers which are part of. Next we have 6. What is 6? 1, 1, 0. So 6 will be a part of this. Done. So what I've done is, I probably have figured out which numbers are part of the 0 bit, and which numbers are part of 1 bit. Something I know for sure is, all the numbers appear twice, or rather even number of times. Even number 10. 4 appears twice. 6 appears twice. 1, which is x, the repeating number, happens to be thrice, which is odd, and y happens to be once, which is again odd. All the numbers are happening even, and x appears to be odd, and y appears to be odd as well. So if you remember, x was 1, y was 5. And if I again just take you slightly back, 1 was 0, 0, 1. 5 was 1, 0, 1. When you solved, you got 0, 0, and you got 1. This bit was differentiating. So that is the reason why was it differentiating. Because at 1, you had 0, and that's why 1 is a part of the 0 club. And at 5, you had 1. That's why 5 is the part of the 1 club. All the other numbers are appearing even days. So if 3 is a part of the 0 club, the other 3 will also be the part of the 0 club. If 1 is a part of the 0 club, all the 1s will be a part of the 0 club. If there's a 2, so if there's 1, 2, which is a part of the 0 club, the other 2 will also be. If there's a 6, the other 6 will also be a part of the 1 club. If there's a 4, the other 4 will always be. So since I know one thing, all other numbers are even times. If I solve all the numbers, if I slow down all the numbers, I know one thing for sure. All numbers are even. So 3 will cut off at 3, 2 will cut off at 2, the 1 will cut off at 1, and there will be 1 left. Amazing. Over here, all numbers are even. 4 will cut off at 4, 6 will cut off at 6, 5. Amazing. So I know there are numbers like there's only one guy left, 1, where there's a part of the 0 club. It's part of the 0 club. There's one guy which is 5, which is part of the 1 club. And these are bound to be the repeating and missing numbers. But I'm not sure either 1 is the repeating or 5 is the missing. I am not sure. But I'm sure that 1 and 5 are my answers. I just have to figure out which is x and which is y. But I'm sure 1 and 5 are my answers. And why am I sure? I'll repeat. Because all numbers appear even times. So when you if you try to put them into 0 and 1 clubs, all the numbers like 4, there are 2 4s. Either the 2 4s will be the 0 club or it will be in the 1 club. There are 2 3s. Either it will be in the 0 club, either it will be in the 1 club. There are 2 6, either in the 0, either in the 1. So at the end, when you take a solve of everything, only the odd guys will remain, and that's why they survive till the end. And that is why I try to differentiate on the differentiating bit. That is my funda. So I have to go through the algorithm again. What do I do at first? I go through all the numbers in the array. It's basically all the numbers in the array, XOR with till n. And probably this will give me a number. What's the next step? Find a differentiating bit. That's what you do. Find a differentiating bit in number. Basically, what is the meaning of differentiating bit? If you see over here, differentiating bit will always provide you 1. Same bits will give you 0. First one you have to find. First one from the right. First one from the right is what you find.
Okay.
What's the second? Third thing you have to do. Once you know the first one, once you know the number, just put them into two parts. First part can be the 0 part, second part can be 1. Once you have this, just have to figure out is 1 the repeating number. Not to figure out, take 1, go through the array. Oh, it happens to be twice. 1 happens to be twice. So I cross check. On cross checking, I know 1 is my x and y is my y. If 1 was not appearing twice, 1 would have been my y and the other 1 would have been my x. Just have a cross check by doing a simple operation. Very simple. Put them into 2 parts and XOR, and you'll get the 2 numbers. Quite simple. I'll code it. It's very, very simple. Don't worry. So let us quickly code up this optimal solution. First, I'll be figuring out the size of the array. What is the next step? If you remember, what we did was we went through the entire array, and then we took all the numbers from 1 to n, and we did it. So
Okay, so got the essence of it, and just I need to be more specific. Okay, let me close this. Yeah, so basically it's the idea that I don't think I'm gonna think at that level, as I was thinking around only hash map and all, but here things are different. Okay, if you see, So basically what they are doing, we have numbers, you can say 3 2 1 1 and 4, let's say these are the numbers. So what they are doing, like if you will get to 1 to n numbers, okay, then all the numbers, if you will take XOR of both, so only the remaining numbers will be the one that is duplicated. So duplicate, you can say duplicate digit or number, XOR uh, missing, okay. Now they just wanted to see, find the, if these two numbers are different. Otherwise, if both are same, then that means all the digits will be same and the value will be 0. So we just need to, whatever the result that we are getting, we need to find the bit, one set bit, and the set bit will be basically odd bit. So you need to find any set bit, okay. Now, so once you got the set bit, that was nothing but the bit that is not matching between those two, that's why it is 1. And now we just need to separate all the numbers into two categories. First, where the bit is, you can say, so based on this, so for 1 it will be 0 and for 1 it will be 1. So if you compare those two numbers, the 1 will be 0. So we are going to group them into 0 and 1, all the numbers, and we do not know whether which one will be what. I just am curious to okay, so let me do one thing. Just want to know, not this terminal, x python 3, so x equals to 5, x left shift 1 2 5 and 2, so 5 will be 4 2 1, so 1 0 1. If we'll shift 1 by 1, then it will be 1 0 and it will be 2. Great, so it's working. Okay, so let me jump to the solution. Okay, so let me not directly jump to the solution. So first step would be just calculate XOR of both 1 to n, and you can say all array elements. And if you know, just we need to add, like when we are iterating to number, so you can take index or whatever way you prefer, and you can iterate all them. Maybe you can use like for I in range or I in range, yeah, 1 to n, and there just start iterating. You can use it, I will use it. Step 2 will be you can find first, you can say leftmost set bit, you can say position of it, and based on that, like we'll use filter. Maybe we can say masking policy, not masking policy. For example, if it is 10, this we are going to just do 1 and this, and then we can use it. So position, step 3 would be, so we have, based on this we will get 0 and 1s, having 1 and 1 having 0, and then add to any number and check in array of numbers. If it is there, that means it's you can say you duplicate, else if it is not, then unique, another one will be duplicate. Okay, so let me jump to the solution, and here we are going to do this for I, you can say jar equals to 0 for I in range num len n equals to len of n nums n. So zor equals to zor of, you can say zor of this one what we have, and we are going to just do the two steps, nums of I and zor nums of zor I plus 1. Okay, so I think, yeah, not I think, then it will be the complete zor, and zor is having you can say while 2, let me do one thing, if zor and okay one, that means if both bits are set, then only will get true, then return, you can say count equals to 0, then break, else just you have to do one thing, zor equals zor will be equals to zor and left shift 1, I mean just we are shifting one bit towards right, and this way we are going to get the value, and just we need to check count, or you can say, yeah, count means plus equals to 1, so that means we just shifted one bit, so it's not at the first place, so it's not 0th bit, or you can say first bit, it is the second bit. Okay, so we are starting from 0, so now this is the condition, and finally whatever count we are getting, so we need to just post it by that number, so mask will be, you can say 1 left shift where is terminal, oh my bad, I mean I need to, I forgot the syntax of what, 1 left shift and then by C and T, I mean yeah, 1 left shift 2, 1 left shift 0, I mean what we are doing, 2, okay, so left shift count, so mask now, if let me start with So 0 equals to 0 and 1 equals to 0. Now for I in range of n, so if nums of I and you can say nums of I and mask, then we need to just, that means it is the bit is 1 for them, so 1 equals to 1 and XOR, that will be this 1 XOR and nums of I. Okay, EL if talking about nums of I and mask, then this, else this. That means it is not working, and so okay, what can we say? 0 equals to 0 and XOR, not this, nums of I. Okay, so this is one condition. And if nums of, not nums of I, basically if I, we need to use I plus 1 XOR mask, not XOR pro, and mask, that means if we are applying mask, so if it is 0 means it is satisfying the condition true, then 1, what will be the one value of 1? So both are 1, then 1 XOR, okay, so 1 XOR nums I plus 1, else you can say 0, we are going to, it is going to fall, 0 XOR and I plus 1. Finally we got 0 and 1. And now I iterate through for EL in nums. If EL equals to 0, if EL equals to 0, that means just break and result equals to can we say 0 equals to zero flag, and we'll say initially it's false, that means 0 is not the, else break and ZF 0 flag equals to true, that means 0 flag is the duplicate. ZD means 0 duplicate. I mean, yeah, though it's a bad habit. If ZD, what was the option here? So duplicate, if ZD, then that means we need to result dot append and 0 and then result dot append, you can say 1, else result dot append 1 and result dot append 0. So we are appending these two and finally return result, and let's see if everything is good, then we'll be able to submit it. Yeah, so everything is, I'm pretty uh, happy that I coded it. No, though I used the method, but yeah, we are able to manage it. So solve it with the help of tutorial, and I am expecting to use the same concept to solve similar problems, and moving forward expecting that you can solve it without looking at solution again. Without using solution. I think I need to practice again once I'll finish them. Then only I'll be able to do it. Mark for revision. Everything is marked for revision, then what is? Let me jump to another question. Okay, it's 12:53, bro. I was expecting that I'll log off early. I mean, I'll just I don't know if I can do it earlier quickly. So we have another problem that says maximum product subarray in an array. Maximum product subarray in an array. Given, what is the meaning of it? Maximum product maximum should be and subarray in an array. Given an integer array nums, find the subarray with the largest product and return the product of the elements present in that subarray. Okay. A subarray is contiguous non-empty sequence of elements within an array. Continuous. So that means following -5 0 0 -2 and 5 0 -2. Okay, so it's kind of similar to the other problem. There we were trying to find the maximum sum, and here we are trying to find the maximum product. So it's kind of similar problem. So can we 4 5 3 7 1 and 2. Okay. So number length can be 10 raised to the power 4. Contiguous means we cannot sort it simply. Yeah. Otherwise position will change. So we need to solve it without using some sort of, where is that whiteboard? So let's see, we started with 5, so we see it's -5. numbers can be into three categories. So first can be positive, negative, and 0. If we are adding 0 to anything, that means it's going to be 0. And when we need to consider 0, if the numbers are negative and we are not hoping to get any positive numbers, so initially we have -5, then we got 0, so we are getting positive number, but okay, that is okay. So first will be the value -5. If we are including the second number, then it will be 0. If we are including the third number, then it will be 0. And if we are dropping the first number, then it will be this number, and finally it will be -2. These are all possible combination. So can we do something? Okay, so we know. So what we needs to be done. So initially we are getting -5. So we have maximum -5. Then we added another number, or we multiplied with another number. Then we got 0. So maximum is equals to 0. And when we are getting 0, that means if we are going to add any number, it will be 0 only. So it doesn't matter. So once we got 0 into something, we got this, and then we added these two, then we got this, and then what we'll do, very simply we got 0. So here we can drop it, or we can say we are not going to get any positive numbers or any greater than 0. So we need to drop this 0, and we need to jump to another number, so -2. So we can see we are getting the and what if we'll do it the same will apply here. So first we got 4, okay, that is okay. Then we got 5, that is okay. Then we got 3, that is okay. So if we are getting positive number, so forth, so that is max. Then we got this number, and suppose this number is negative. But what if it is minus? -7,652. So first we got this number, Then we got this number, so we continue this number. These are positive, these are positive, so that so far we are great. Over 4 we have 60. Then we got -7. So far we have 60. And when we added -7 to it, it became negative. And then we added this number, then it's still negative, minus negative, minus minus. So if we are getting 0, if 0, drop that and start from next number. So that is one thing. If negative, there are two cases. If minus in future, can be useful. Else drop it, start from next. I know these two options are very vague. This one is clear. Drop that and start from next number. Here I'm just confused. How can we say it? These 4 5s are 20, 3s are 60. So this is just nothing but 60. I mean, really, I feel tricky these problems. I don't know. Okay, I think. Yeah, so I was just trying to approach using some methodology. So I know minus has two options. Minus can be useful if we have another minus, uh, and it also depends on till where we can use it. If we got minus another, so we have 4 5 3. Okay, good. Then we got -7. One way is to calculate. No, we cannot. What if there are zeros? We need some strong solution or technique. I mean, yeah. So I need something that is more inclined towards it, or that is favorable to minus conditions. I know zero if there is, then simply okay, but we haven't took the condition if we have zero as well as we have negative positive. Then how are we going to tackle them? I'm really confused about it or what. Okay, what I'm thinking, maybe I need to take time and today we can drop the idea of solving it. Otherwise, I need little more time to solve it. And it's better if we can come up with an idea tomorrow. Maybe I'll think more on it. And also, the reason for that is I can't do it in a hurry. I have to take time and think about it. I think it's a good problem and it's going to help me a lot. So let's maybe we have solved one and we will solve it tomorrow. And the problem is like it's 1 a.m. and I'm just wanted to I have to go office and maybe tomorrow I'll have to go gym also too. So that's why. So let me stop and thank you. Bye bye.